Hello, everyone, and welcome to a very new topic. So, what I'm doing today is the topic of what we call computation with positive integers. So, doing basic arithmetic that we've hopefully been exposed to now in elementary school or primary school. And I'm going to start this off by talking first about adding and subtracting these positive integers, these positive numbers. And then we're going to move on to some more concepts as we go through this series. So, adding and subtracting. Now, hopefully by now, we've all had some experience in doing this, but let me just give you a quick rundown of how we can think of adding and subtracting, as well as some key ideas that come along with this. So, say I wanted to add 3 and 4. Now, this symbol here, I'm sure we've all seen it. This little plus here implies or shows us that we want to add these two numbers together. So, in essence, what we're asking here is in a sentence, what is 4 more than 3? That's really what we're doing here. In adding numbers, we're just trying to find what's one number more than the other. What do we get when we put those together? And a good way to visualize this is through a number line. So I've drawn one here, and a number line is just shown to represent all of the different numbers as they go from small to large. So I'm going to start with, for example, 0 on this side, and I'm going to go all the way up to the number 8, 4, 5, 6, 7, and 8. Cool. So I have my number line here, and I'm trying to find what is 4 more than 3? So I'm going to start at my number 3 here. That's the very first place I begin. I'm showing that here. And I want to find what 4 more is than that. So I can just hop from this number. Well, let's think. Am I going to go in this direction or this direction? Well, the number's going to be bigger. So I'm going to be looking at this direction here. My number, when I increase 3 by 4, it's going to get bigger, right? So it's going to get bigger by 1. Whoops. Not what I wanted to do. By 1, 2, 3, and 4. So what number do I end up on? Well, I get to 7 here. So when I find 4 more than 3, that gives me 7 when I add these two numbers together. Now, let's just look at something interesting here. What if I changed the order of these? Let's see what kind of difference that makes. So if I, for example, did 4 plus 3. So if I was looking at, for example, what is 3 more than 4? Okay, so in doing this, I'm going to once again draw my number line here. And let's do the same little intervals. 4, 5, 6, 7, and 8. So let's look at the perspective here. We're starting with the number 4, and I'm trying to find what is 3 more than that. So drawing in my 4 here, I'm going to go 3 spots to the right because I'm finding what 3 more than that is. So if I go 1, 2, 3, lo and behold, I end up at the same number. So in maths, there's actually a law for this, and it's a pretty big word, but this law is called the commutative law. Don't get too fixated on these really big, scary sounding words, because I'm going to quickly define it here for us. All that this thing tells us is that when adding numbers, the order we add in doesn't matter. That's pretty much what this thing is telling us. So in other words, from what we saw in our little investigation here, no matter what order we wrote these in, we got the same answer. So I can show that by saying, well, 3 plus 4 from what we found is the same as 4 plus 3. That is the commutative law, that the order in which we add, whether we put the 4 first or the 3 first here, doesn't actually matter. We're always going to get the same answer. And when we do this for, say, more numbers, we're going to identify another one here. So let's look at adding some numbers again. Now, I'm going to do another example, call this example 2, and I'm going to take, for example, 4 plus 11 plus 3, and I want to add this all up. So what I'm going to do this in 2 ways. Say I can't do this all in my head, and I want to break this up into like smaller bite-sized bits. So what if I first decide to add, in approaching this question, add these two together first. So if I add 4 and 11, I get 15, and I'm still plussing the 3 to that. So if I do 15 plus 3, I get left with 18. Now let's take this same thing and do it another way, for example, and see if that changes where we get to. So I'm doing the same numbers here, but a different approach. Say, once again, I didn't know how to add all these all together. Let me just do this in smaller bits. But first, instead of adding 4 and 11, I'm going to add 11 and 3 here. So my 4 stays, and I'm going to add to my 4 what 11 plus 3 is. So 11 plus 3 gives me 14. I'm looking at 11 more than 3, or 3 more than 11. And I end up with the same thing. So let's just actually look at what we did here. Well, we added 3 numbers together, but the order that we added them in, we changed. So for example, and we saw that the answer was the same. That's a very important idea too. But let me show this in terms of using brackets, which we're going to talk about a lot more. But these brackets, I'm just going to use to symbolize what we did first. So I'm writing here the order that we added these things in. So let's fix that. And let's center this. So showing this thing here, see how at the top I added the 4 and 11 first? I'm just showing that by drawing in these brackets. Now, in the second case, we added 11 and 3. So I'm showing that with these brackets here. And we can see that the order in which we added these in, once again, didn't really matter. And there's another name for this. This is called the associative law. Once again, these are really big words. I don't want you to get too caught up on remembering all of this stuff. These are more just ideas, basic ideas that we experience, that we look at when we think of patterns in adding these numbers. So this law just tells us that it doesn't matter which pair we add first. So which pair of these numbers? So see, we split these three additions into pairs first. So we had these two numbers. A pair just means two, and another pair here. So no matter which ones we did first, which pair we did first, we got the same answer. So the associative law tells us it doesn't matter which pair we add first, we get the same answer. Same answer. So let's just end the video here. I'll do this in two parts. We've just covered addition, mainly in this video. And in that, we've talked about two pretty key ideas. And this is the commutative law, the one up here, which tells us that when adding numbers, the order in which we add those two numbers doesn't matter. And the sort of second follow-up bit to that is the associative law, which tells us something about when we add more than two numbers. So if we add, say, three numbers, the order in which we add them, the order in which we pair these here, doesn't actually matter. We're going to get to the same thing. We notice here that both of our answers, whether we added the 4 and 11 first or the 11 and 3 first, we got 18 in both cases. That's what the associative law tells us. And we looked at this idea of a number line. So if I draw a number line, so this is just a horizontal line that shows us the progression of numbers, these whole numbers, these integers that we've learnt about in elementary school. And as I go to the right, as I move to the right of this number line, my numbers are going up. So the right-hand direction here, we are going up in value for each of these numbers. Now, we can also go the other direction, but we will talk about that in the next video when we look at subtraction. But anytime we add, we are moving to the right. When we add numbers to each other, we are going to get a bigger number. So it would make sense that we go from left to right here. Thanks so much for joining me, guys. I'll see you in the next video, which we're going to be talking about subtracting numbers. I'll see you.